Hey, what's going on guys? This is Big Brace channel. My name is Amir and today we're going to build a practical and useful application, a personal budget tracker. Now this project is perfect if you're just starting with Go or want to reinforce your understanding of the basics. And I'm not sure if you're watching this before or after my Go course. I will assume that you have an understanding of the basics of the language. And if not, I will do my best to explain each code line in a detailed way. This app is designed to help you manage your finances by tracking your income and expenses, all while demonstrating the fundamental concepts of Go, of course. And I've created budget trackers in a lot of languages like JavaScript, C, but honestly, by far the language that I enjoyed the most is Go. And I'm not promoting the language here, I'm just simply telling you my personal experience with the logic flow of code in Go really feels good. By the end of this tutorial, you will understand data types, control flows, loops, functions, structs, methods, interfaces, and how they all come together to build a real-world application. You can improve upon this application by the end of the tutorial if you want. And if you're watching me for the first time, thank you so much for tuning in. Please consider subscribing to the channel, hit the like button, share this with your friends if you find it useful. And with that out of the way, let's go ahead, roll up our sleeves and start creating our budget tracker in Go language. So let me first go to the folder where I want to create this project. So let me call it expense_tracker. Alright, and let's open this with Visual Studio Code. Then I will create a file. I'm going to call it main.go as always. Alright, so first thing you want to do always is to get your main package. That's the main package. That's very important because we will have our main function that is our main entry point to our application or our website or whatever. Alright, so that's the main function. The first step in our program here, and what I always want to do and any other Go programmer do, I suppose, is to import the required packages first. So import the required packages, and that is done by the keyword import. If you're going to import only one package, that's going to be enough to do it on one line. Just import and let's say FMT, the format package, and that's it. But as we're going to import more packages, so what you would want to do is to open parentheses, and inside the parentheses you're going to enter all of your packages. And you can see that tab 9 actually is suggesting that. The first package that I need in my program here is encoding CSV. The encoding CSV package provides functions to read from and write to CSV files. Because I designed this program not only to be a command line interface where you can enter your income, your expenses, to show the transactions and so on, but also with the ability to save everything or save all the transactions in a CSV file. So I think that's an awesome touch. Also, we need the format package. The format package implements formatted I/O functions in general, things like printing, scanning, and so on. Also, we would need the operating system package, and that provides functions to interact with the operating system. And that's going to be mainly used here in our application for file handling. Also, I would need the strconv, and the strconv is a very famous one that contains functions to convert between strings and basic data types like int, float, and so on. The last package that we need in our program today is time. The time package is used in general in any other programming language, not only Go, like Python, JavaScript, and so on, to provide time-related functions. Here in our application, I'm going to use it specifically to get the current time when we're going to record a transaction. Now that we are done from the first step, which is importing the required packages, I'm going to move on to step 2, which is defining the transaction struct. Now, if you don't know what a struct is, and if you're coming from a Python background, for example, a struct is analogous to class in Python or a prototype in JavaScript. So that's a blueprint essentially, and you're going to have different variables, and for each variable you will need to define the data type of that variable. So that's going to be also in the global scope here, and remember that the global scope is anything outside the main function. Inside the main function, that's the public scope, And outside the main function, that's the global scope. So I'm going to create now a transaction struct to hold each transaction's details. And by the way, notice now when I will do Control S, you will find that all of those packages will disappear, because Go imports automatically the package whenever you're going to use it. So take a look, Control S, and they're all disappeared. It doesn't really matter. The most important thing is that you know what are the packages that we're going to be using. So let's create that transaction struct, and it should of course start by the keyword type transaction struct. And inside curly braces, we will need to have different variables or different fields, if you will. The first one is ID, and that's going to be of int data type. Also, I will need an amount, and that's going to be float 64. That's floating point 64 bits. Also, I will need a category, and be careful that they all start with the capitalized letters. So amount with capital A, category with capital C, and so on. And that's going to be string, right? Also, I need date, and that's going to be time.time. Now take a look, when I will do Control S, it has imported automatically time. Of course, it didn't open the parentheses for a lot of packages, because so far we have imported only, or we have only used time. That's why it has imported time only. And that's a package that provides functionality for measuring and displaying time. Yeah. Awesome. Next, and the final field that we need is type. And type here is going to be string. Type is whether income or expense simply. So that's the first struct that we need. Later we can instantiate that struct by creating a struct instances or objects, and that's going to be exactly the same thing for the budget tracker struct. So I need budget tracker struct to manage the transactions. Awesome. So again, type, and I'm gonna call it budget tracker. That's of data type struct. Open close curly braces. The first field is transactions, and this transactions field is going to be a slice of the transaction struct that will store all of the entries. So what you want to do is to open close square brackets, following that the transaction struct itself. And of course we need next ID, and that's going to be an integer data type. So remember that in the transaction struct we have an ID, but in the budget tracker we have a next ID field, just to keep track of the next transaction ID. All right, that's awesome. Now that we are done with both structs, let's go ahead to step number 4 to create our financial record interface. Now, interfaces look like structs, but an interface doesn't have variables like transactions, next ID, all of these are variables, but instead it has methods. So this interface basically is going to be used for common behavior. And as I told you, it will hold inside it methods and not variables. These methods we are going to create later. So just to create an interface that's going to be exactly like a struct, we'll start by the keyword type, and then the name of that interface, I'm gonna call it financial record. Following that, the keyword interface, also with curly braces, and inside here, instead of variables, we'll have the two methods that we're going to create are both getters. Get amount and get type, because we need the amount entered and the type of that transaction, whether income or expense. So get amount, and here that's going to be of float 64 data type, and also get type, and that's going to be of string data type. And this in fact demonstrates what we call polymorphism. I don't know if you know this word or not, polymorphism, but this simply refers to the ability of a function or method to process objects differently depending on their data type or class. And in Go, actually, the interface is the key to achieve polymorphism. All right, so maybe you need to keep that in mind. So can type here, interface is a key to achieve polymorphism. And by the way, you will find the code in the description below, the GitHub link. So feel free to clone it and, play with the code after. Achieve polymorphic behavior or polymorphism. That's the same thing. All right, so now that we're done with our two structs and the interface, we will move on to step number 5 to implement the interface methods here, the getAmount and getType, to the transaction struct. Right, so we will need to do that in step number 5 here. So again, I'm going to leave a comment for you guys when you will have the code. Implement interface methods, the getter methods, the getAmount and getType for the transaction struct, the first struct that we have created. So the way to do that is by creating two different functions, one for the getAmount and the other one for the getType. So we're going to create the first function by the keyword func to define the function, and this function takes the transaction as parameter. So you can see that this t here is the input, and that's of the transaction struct. So this transaction actually can be an income transaction, and that represents any form of incoming money like salary, other source of revenue in general. It could be freelance payment, whatever. And also expense transactions, and that represents also any form of outgoing money like paying rent, utilities, groceries, presents, other costs, whatever. All right, so that should be the input here for that func. Following that, the getAmount method, and this should return a data type of float64. And this returning here, of course, the t.amount, the transaction.theamount of data type float64, of course. Also, we will need the second one. So that's going to be, instead of that getAmount, that's going to be getType. And instead of float64, that should be string. And inside of t.amount, that should be t.type. All right, now I think the idea is clear. Simply, those two methods allow the transaction struct to satisfy the financial record interface. And that makes it more flexible and allow potential expansion in the future if you want. Now that we are done with those two methods, we will move on to step number 6, which is to define the addTransaction method. And to do that, I will need to create another function, BT, and that stands for budget tracker. So asterisk budget tracker. Awesome. And that's going to add, wait, hold on. I hate this tab 9. Wait, hold on 1 second. I'm going to snooze it. Okay. So I'm going to give a name to that function, add transaction, and that takes an amount of data type float64 and also takes a category, and that should be any category that you want depending on the type of the transaction that you want to do. So it can be rent expense, salary, income, whatever. And also the transaction type, and that's going to be string. So the transaction type, whether income or expense. Then let me instantiate that transaction struct by creating a new transaction object. New transaction. And I'm going to declare and initialize in the same time. And that's equal to the transaction struct. And inside here, we will need the different fields. And we will need different attributes or different fields. So as far as the ID, that's going to be bt.nextID. Also for the amount, that's equal to amount. For the date, time.now. And finally, the type is set to the t type. Right? You won't find any problems understanding that. That's very, very similar to Python classes and creating objects and instantiating them from the main class. Right? So we have our data attributes set, the ID, the amount, the category, the date, and the type. Then I want to append the transactions, a new transaction. By the way, guys, this I just passed quickly on this one. The asterisk budget tracker, that's a pointer receiver. Okay, the pointer receiver ensures the original struct is updated always. So that essentially is going to show us how to modify this transaction slice, right? By using this pointer receiver, where is it? Budget tracker right here. And the ultimate goal of that is to make sure that the tracker is always updated with data. So let me just add a final line here, or two lines rather. The budget tracker dot transaction slice, transactions slice. And here we're going to append to that slice the transactions and the new transaction if there is, right? So that's a method called append, bt.transactions, but also a new transaction. All right, guys, so don't be confused. That bt is simply an object. This object is of that budget tracker struct. That's an instance of the budget tracker struct. All right. And simply what we want to do next is to take that bt object, and we want to access the next ID field. Remember, we have here the next ID in the budget tracker. Where is it? Here we have this one. So of course, any object of the struct can have access to any fields of that struct. So we're accessing actually next ID, but we're not only doing that, we are incrementing it by 1. And that line simply makes sure that after each transaction, this transaction will have a unique ID. Okay, that's all what it is. It creates a unique ID for each transaction. So transaction number 1 will have an ID of 1, transaction number 2 will have an ID of 2, and so on. All right, now with that, we will move on to step number 7, which is creating the display transaction method. This method actually is going to print all the stored transactions in a tabulated format. It introduces actually how to loop over slices and format output nicely. So creating display transactions method. So I'm going to say func, again, that instance of the budget tracker that's called display transactions, and that's inside here. We will have to print out println, and we'll say here ID and the transaction amount. We also want the category, right? The category, the date, and the type. Then I will loop over for the first argument is not important, so I will add this, and that's actually called a blank identifier. So it's used to ignore a value that you don't need or want to use. And in Go, there is something called range. If you don't know, that looks like in Python, two values are returned: the index of the current item of the iteration and the value of the current item. So you have the index and the value. All right. So the index is not important, but we need the value. That's why the first one is ignored. And the second one, which is the value, is very important. That's the transaction. So for underscore transaction, that's equal to range, right? bt dot transactions slice. And here we will format it again. So first of all, the %d, this is used to print an integer. In our case here, that's used for the transaction ID. Take a look, we have our first field is the ID. Next, we have a \t. This represents a tab character, okay? Because we will need some spaces between each field. And as I told you, that's going to be in a tabular form. It will look nice, believe me. It doesn't have any lines, but still it will look nice and very much readable. So after that t, we have .2f, and that's going to be the transaction amount. And 2f means that 2 decimal places. So that's going to be 10.50, for example, 10.50, instead of being 10.4999 something. Next, we have s, and this is for the string. So in our case here, we will have this transaction category. And category here, like I told you, groceries, rent, salary, whatever. Next, we have the transaction date. And the transaction date is going to be formatted this way: years, month, and date, and days, sorry. Okay, so Y, then MM, and DD for days. And the last S, the type. And the type, as we said, should be either income or expense. And I don't have to tell you that this is the new line escape code. So what I want to do next, or what we're going to move to, is step number 8, which is getting the total income or expense. So this function here, I'm going to, this function here, I'm going to create it, and I'm going to pass, of course, the BT object of that budget tracker struct, and I'm gonna call this function calculate total, because basically I want to create a total and add to it the amount, or increment to that total the amount, whether it's income or expense. So let's see how we can do that. Calculate total. Let's try to be a little bit quick. I'm trying to explain every little thing for you guys. So if you're not aware of the basics or the rules of Go, you won't be too lost. Okay, so I'm going to I want to declare a variable here. I'm gonna call it total, and that's going to be of float 64 data type. Next, I want to check out for any, the ignored value. The first value is the index ignored value, and then after the transaction, it's going to be the amount, and that's equal to the range of the bt.transactions, and we'll open curly braces, and we'll check out if the transaction dot type is equal to the t type. The t type. In that case, I will increment the total by the amount of that transaction. I'm being a bit hasty. I apologize, guys. So yeah, transaction dot amount. And finally here we will return the total. Awesome. So let's see what we have created so far. First of all, we have created two structs, the transaction and the budget tracker. Then we have created the financial record interface for the two methods that we have, the get amount and the get type. Good. Next, we have implemented the interface methods for the transaction struct. So we have here the t.amount and t.type. Then we have moved on to add a new transaction. So this new transaction is going to be used essentially to add any sort of transaction depending on the amount and the category that we're going to enter. And each transaction is going to be stored with a unique identifier. Next, we have created the display transactions method. And that's very important. That's going to be, and this is very important transaction, and that's very important function. That's essentially one of the options that we're going to choose in our CLI application. Then we move on to get the total income or expense by incrementing the total by the amount of the transaction, and finally we return the total. Now we will move on to saving the transactions to a CSV file. You can escape this step if you want, but I find it very nice. Okay, so let's go ahead and write the comment, save the transactions to a CSV file. Besides going to teach you how to interact or how to create files, how to write to files, how to read from files, and so on. So that function, again, is going to take BT as the parameter or the main parameter. And this is the instance of that budget tracker struct. And I'm going to call this function save to CSV. And this is going to take the file name as an input because you're going to save it with the name that you want. So that's going to be of string data type, of course, and potentially this function can return an error. So we're going to say file and error are equal to operating system package.create. We're creating here a file, and that file is the file name that you're going to give to the program. Now I'm going to check out if error is not equal to nil, which means that if error is not false or if error is not empty, which essentially means if error exists. In that case, we will return that error. Following that, the keyword defer file.close. Defer is a very important keyword that simply is going to delay that file close action till everything around that function is completed. Okay, so it's not going to do it right away. It's going to wait until the error is returned and then the file.close is being invoked. All right, and why is it complaining? Missing return compiler. Yeah, we can return okay, just to let him be quiet. But then after the defer keyword file.close, I want to declare and initialize a variable called writer, and that's going to be equal to the csv.new writer. This method is very, very important. That's actually going to write to the file. Okay, and also we're going to defer, but in that case we're not going to do file.close, but we're going to take the writer.flush. So let me explain. Here we have created a new CSV file with this csv.newWriter file function. This creates actually a csv.writer object. And the file being passed here, that's a handle to an open CSV file where data will be written. All of the transactions, the dates and everything are going to be written to that file. Defer, we have explained it before. Writer.flush. The flush method is very important or crucial, I dare say, because it ensures that any buffered data is written to the underlying file. So the CSV writer buffers its output for efficiency, and flush is going to be called to ensure that all data is actually written to the file before it is closed. So if you will comment this line out, you might lose data. So I might add this comment here. Flush is very important to make sure that data is written before the file is closed, right? So that's very important, guys, to understand. By the way, guys, let me know in the comment section below, what do you think of the Go language? Do you love it or do you hate it? So the next thing that I want to do is to write the CSV header, and to do that I'm going to take the writer variable or object dot write method, and that's going to have a slice of the string, and that's essentially going to hold different fields. So we need the ID, the amount, the category, the date, and the type. After writing the CSV header, I want to write the data. So to write the data, I'm going to loop over the range of the BT or the budget tracker transactions. So for index, that can be anything actually, it doesn't matter. This value is going to be ignored. And the second iterator, that's the value, the amount, that's essentially the transaction or the T object of that transaction struct. And that's equal to the range of that budget tracker transactions. So range bt.transactions, and inside I will have record. This record is actually a slice of strings which is created to hold the formatted data for each transaction. So first of all, strconf.itoa, integer 64, sub I as first argument and 10 as second argument. And that means in plain simple English that it's going to convert the transaction ID to a string. So each transaction has an ID number. That's the first action. The second one, format.sprintf, and that will take 2 decimal points to f. That should be a string, right? That should be a string, and this is the transaction amount. So again, it's going to take the amount, which is float 64, and turn it to a string. Next, that's going to be the T category. We're not going to convert anything. T category, because that's a string. And the date, that's formatted as date. So we will need to do t.date.format, and we'll do here 2006, like we have done above. 01, that's the month. 02, that's the day. And finally, I need the type, t.type, whether it's income or expense. All right, awesome. And this is of course complaining here because that's declared but not used. And then finally here at the bottom, I'm going to write the record to CSV. So I'm taking the writer variable or object dot write method, and I'm passing the record. And now that squiggly line has disappeared. And it's complaining here. Let's check out why. Oops, yeah, that's right. Apologize for that. All right, so the record here, that's var record string slice, right? Everything looks good to me. Maybe we can add a confirmation message to the console, format.println, and we can say here transactions save to and the name of the file. Awesome. Now let's go ahead and run our main function to finalize our application. All right, guys, we are in the last step, step number 10, to create our main function. So the first thing in the main function is initialization or instantiation rather of budget tracker struct. I'm gonna call it BT. Yeah, BT equal to budget tracker struct. That's the first thing. Next, I want to loop over the choices. So I will say here, so that's going to be the main display or the main interaction. When you're going to run the application, you're going to see that. The first thing that you're going to see is that we're going to write right now. So print ln, and we'll say here, so /n, and we can do 3 hyphens. You can say here personal budget tracker, 3 hyphens again. All right. So the first option, oops, got carried away. So the first option here is add transaction. So that's the first option. Maybe I can just delete all of those and make that again like this. Yep. The second option is to display transactions. Remember that beautiful function that we've created to display the transactions. The third option is show total income. Total income. And also show, it's going almost to be the same. Show total expenses. And the fifth one is save transactions to CSV file, right? And can add 2 more. And the last one is just to exit the program. And you can add here, choose an option. Or choose right, so choose an option. Right, so that's the main interface. Let's go ahead and try that, by the way. We'll see if we'll get any errors. So we can compile the file or we can run it directly. So to compile the file, you can do go build and an output file. I'm gonna call it main.exe. We will need the mode. Okay, so go mode init main. All right, now go build again. Yeah, the BT declared and not used, missing argument in conversion, but I think it has the mode. It didn't compile because of that silly error. So yeah, what we can do is actually I can comment this line out, and if we will build again, I think we will not have any problems. Yeah, there we go. We have our build successfully made. All right, so it really doesn't matter. You can do main, you can run the file like that, or you can do go run main. Doesn't matter. So let's run it this way. And of course, that's an infinite loop for all of the options. So Control C to shut that craziness. And just to show you, that's going to do the same thing. And this is geared mainly towards beginners, just to show you guys that both ways are going to work. So go run main.go, that's going to do exactly the same thing. Control C to kill that. And let's move on. So let's have different choices. So whenever you will type 1, 2, 3, and so on, that's going to be stored in a variable called choice, and that's going to be of int data type. Next, I want to read the user's input and store it in choice. To do that, I'm going to use the format package again, and I'm going to use scanln. And that's going to take this user's input, which is the number essentially, that's stored it and store it in choice. So that's not going to be only choice, but with ampersand, right? Because that's a reference to the choice. Then next, what I will need is to have switch case. Now, switch is going to behave exactly like if-else statement. Because this application or this program that I designed for you, I designed it specifically to have a lot of the basics of Go language. Instead of teaching you one by one, of course I have my Go course, but this is more practical. So we're going to type the switch keyword here, and we're switching choices. So if the user choice option is 1, we're going to prompt the user for transactions amount. If the user choice is 2, we're going to display transactions. If 3, to show total income, and so on. So we have different cases here. Case 1, and we're going to take more. So 2, 3, 4, 5, and 6. We don't need more than that. So for case number 1, the first thing that I want in that case 1 is to prompt the user for the transaction amount. So we will need different things in the same case. Still in case 1, we will need to prompt the user to enter amount, enter category, enter type, income or expense. And then finally, we should notify the user by a confirmation message that the transaction has been added successfully. So to do that, let's go ahead and try to be a bit quick. Print, just here, enter amount. And I need to declare a variable to store the amount. So float 64. And I want to read the amount input by the user. So format.scanln. And again, I'm using the same technique of referencing to the amount's memory address. So at amount. And also, so that's for the transaction amount. And I need 3 more. So 1, 2, 3. So I need 3 more. 1, 2, and 3. Oops. Okay. So the second one is enter category. That's a string, right? Also the type, whether income or expense. And that's of course going to be a string as well. And here is, instead of amount, oops, I forgot to see here, that's amount. Here is category. Right, and here is type, so that's going to be T type, right? That's T type. Okay, awesome. And finally, just maybe you can make like that. Okay, and finally here we'll just do that print ln and say here something like transaction added, right? And we don't need that. And also we can do here the bt dot add transactions, so the budget tracker dot add transaction method and or function that we have created. Actually, we need to pass inside the amount, the category, and the T type. All right, awesome. So this is as far as case 1. As far as case 2, we will simply do bt.display transactions, because that's all what it is. For why it is giving us, oh, because I've commented it. Yeah, I've commented out. Okay. Right. As far as case 3, we're going just to print total income, and we are just getting the total income using the budget tracker object.calculate total to display the income. The exact same thing for the expenses. For case 5, we're going to prompt the user to enter the file name to save the transactions to the CSV file. So we're going to say format.print. I'm going to say here enter file name. We can give the user an example, transactions.csv. Okay, should be with the extension, of course. And that's going to be left to you, the user. Next, I want to declare a variable to store the file name. So file name here of data type string. So format.scanln, and again using ampersand file name. Awesome. So that's going to read the file name input by the user. And in case of any errors, so bt dot save to CSV method passing inside the file name. We have created this save to CSV function above. So if the error is not equal to nil, I'm going to just write a message here, print ln, and I'm going to pass here a message, error saving transactions, and I'm going to show the error after. All right, and case number 6, if the user is going to exit the program, we're going simply to print exiting. So format, we're done with the program, guys, by the way, so get ready to test it, exiting the program, and we're going to return. And we can have a default case. So if the user input any invalid option, if they will enter characters or any number other than 1, 2, 3, 4, 5, 6, we can make an invalid choice message jump to the user's face, telling them that that's an invalid choice, please try again. Of course, you can do better than that, I know, but that's just a simple program to demonstrate the core basics of the language. Print ln and do invalid choice, try again. All right, there should be another curly brace, I think. That's the for loop. Oh, okay, so I see. So that should be down here below. Yeah, there we go. All right, guys, all of that inside the function main, or the main function, and all the code that we have written is in that for loop, exactly like while true. Okay, for, and it's going to get in that loop, and it's going to be open unless you hit 6 to return to exit the program. All right, moment of truth. Let's go ahead and try it out. Let's actually compile again. Line 108, missing argument in conversion to budget tracker. All right, line 108. Oh, I see, that's a silly mistake. That's not parentheses, this is curly braces. Okay, that's a struct, right? A struct has key value pairs. All right, guys, so let's go ahead and try that out. I'm not going to compile the code, I'm going to run it directly. Go run main.go, hit enter, and there we have it, personal budget tracker with different options. So display transactions first, of course nothing, but you can see that it's in a form of table, ID, amount, category, date, and type. Show total income should be nothing, total income 0, total expenses 0 as well. Save transactions to CSV file, we're not going to do that yet. 6, exiting, and perfect. Everything seems to be working fine. Now let's try that one more time to add transaction. Let's do 1, enter amount, let's say $100. Category, let's do salary. Income or expense, we can say income. And there we have it, transaction added. If we want to display the transactions, let's see if we'll get any errors here. I should say we shouldn't get any errors because it was compiled in the first place, so we won't expect any errors. So ID, we have 0 ID, that's the first one. Amount 100, category salary. Date, I know that the tabs are not well done. So we need that date to be a bit here and then income to be under type. So we need just to shift that from the left to the right a little bit to look better. This is very easy problem to fix, only to define the header with fixed width columns. That's all. It's just a formatting or proper formatting issue. It's not big deal. We can see it later. So that's the display. It's working fine. So we can see the total or show total income. That's number 3. Let's hit number 3, hit enter. Total income 100. We don't have any expenses yet. So why don't we add another transaction to enter an expense? So let's say, for instance, 10, amount of 10, category, let's do expense. Hit enter, or, oh, I should have written rent expense. Okay, doesn't matter. We can do here expense again. Awesome. So we can display transactions again. And let's have another transaction. Let's say, for example, that, oh, I wanted to do 1 to add transaction. Let's say 5, and that's, for example, gas, and that's also expense. Okay, now we can check out. We have here 2 expenses and 1 income. Let's also check number 4. So we have here total expenses 15. So for example, let's have another transaction. That's number 1. Enter, let's say 4, gift. That's an income. Okay. Now, if you will show total income, you will have here 104. And if you will show total expenses, you will have here 15. Now let's try to save the transactions to the CSV file by hitting number 5. And perfect. Enter file name and our example. So I'm going to call it as it is, transactions.csv, hit enter, and there you go. If you will click on that CSV file, you have here all of your transactions recorded and saved in that transactions.csv file. And this is it, guys. Thank you so much for watching. I hope this tutorial was useful to you. I hope by now that you have understood data types, control flows, loops, functions, structs, methods, interfaces in Go language. And if you have any questions, please let me know in the comment section below. Don't forget the GitHub link repo in the description, and feel free to share with me your ideas about improving this application from interface to colors to functionalities. You can share with me in the comments section below, or you can write me on backbrace@outlook.com. Thank you so much one more time, and I will see you in the next video. Till then, stay safe and be well. See you later, guys.